To create a new implement, enter the implement settings, then select New. The first option you will have when creating an implement is to specify whether you are doing any application control or not. This is where you will select the type of application control being used: Isobus, Field IQ, Serial Rate Control, or Virtual Section Control. For this example, we are going to select None and look at the fundamentals of setting up an implement. The setup of specific flow and application controls are covered in the following tutorials. Here you can specify the type of operation you will be performing, which determines some of the implement settings in the following pages. This example, we have selected tilling. Use the next arrow to move forward and then specify the type of implement being used. Use the next arrow to move forward to the next page. This is where you can customize the name of your implement. Press the next arrow to continue. This is where we specify the hitch type and the hitch to application point. Hitch type can either be a drawbar or fixed mount. Drawbar is referring to the implement being coupled to the machine via a drawbar pin, which means the implement can articulate. Fixed mount is referring to the 3-point linkage type apparatus where there is no articulation between the implement and the vehicle. If selecting a drawbar hitch type, you will then need to enter the hitch to ground contact point. The hitch to ground contact point is referring to the distance between the point where the implement couples to the machine and where the implement touches the ground or rotates from. For example, this would be the axle of a single axle boom spray, or the midpoint between axles on a tandem axle implement, or the center row of tines on a planter or tillage type machine. This measurement is used in conjunction with the vehicle's measurements to calculate the vehicle modeling as the vehicle and implement articulate. As there is no application control with this setup, the implement ground contact point is where the coverage mapping will be measured from. When we are setting up a form of application control, you will see there are additional measurements we enter measured from the implement ground contact point. If selecting fixed mount as your hitch type, you will have to enter in a measurement which is hitch to application point. This will be the measurement from the 3-point linkage hitch to the application point of the implement. Another thing to note when setting up the hitch type is that if you are using an implement that may still connect through a 3-point linkage but still pivots on a central pin, it is best to compensate for this by setting the implement as a drawbar hitch and allow for the extra distance in the fixed axle to toe hitch measurement within the vehicle setup. Press the arrow to move forward to the next page. In the measurements sections, we specify our application and our swath width, as well as any overlap that we may want to apply, as well as implement offsets. Application width is referring to the actual width that the implement applies product or engages with the ground. To calculate the application width on a planter or seeder, measure the distance from the two most outer tines and then add the value of the row spacing. Row number is referring to a planter type application. Enter the number of rows on the planter. On an air seeder, you can enter the number of tines, or on a boom spray, the number of sections. However, this value is only necessary if running a planter type application. The swath width is the width in which you want the guidance lines to be spaced apart. Typically, if running RTK, your swath width will match your application width. If your swath width is narrower than your application width, you will see overlap displayed below. If your swath width is wider than your application width, you will see a skip value displayed below. You may have a swath width different to your application width if you are running a controlled traffic type situation, and there are slight differences in the implement width, but you are required all applications to follow the same guidance line. In this case, it is important that all implements are set with a swath width of equal value or a multiple of that value. Overlap or skip will be self-populated depending on your application and swath width. If you are running the same application and swath width, but want to introduce some intentional overlap, you can manually enter this in here. Left-right offset is referring to the center line of the implement in relation to the center line of the vehicle. It is always important to make sure that the vehicle's roll calibration is completed successfully if you are trying to calculate an implement offset in the field. The physical width is referring to the actual width of the machine itself. Some machines may have frames that are wider than the actual application point. This physical width measurement is what the system will use to calculate end-of-row turns and boundary avoidance. The physical length is the measurement from the hitch point back to the widest part of the implement. Press the next button to move to the next page. If running application control, this is where you can configure that. The steps will be covered off specifically for each type in the following tutorials. Press the next to view the summary. The summary page provides you with an overview of the implement settings. If they are correct, press the green tick to save your new implement. Your new implement will now be listed in the list of available implements. If you have more than one implement, you may need to highlight the new implement and press select. You can make a copy of your implement if you are requiring to have an implement with slightly different application widths. This will allow you to just change the one setting without having to go through the whole entire process. To create a copy, highlight the implement that you want to copy and press Save As. Edit the name and click OK. Now you will have a duplicate of your implement.